topic is Z transform, and in the previous lecture we have stopped our class when we completed the theorem proof of the theorem, initial value theorem and final value theorem. This was the lecture which we have completed in the previous class. So let us continue with the same theorem, and we shall do one example of the theorem. And the example is, this is the example we have. It is given to us that u of z. U of z is what? This is a function of z, that is 2z square plus 5 of z plus 14, and it is divisible by z minus 1 raised to power 4. And with the help of this, what is this? U of z, and you know that u of z is, it is the function, or it is the z transformation of un, and we know what is the un here. And the question is, from this we need to find out u2 and u3. So we want to compute the second term u2 and the third term u3, and we know that for this we have the theorem, that is the initial value theorem, which we have done in the previous class, and we shall use that theorem. So let us use u of z is what? It can be written like this, that is 1 over z square can be taken common in the numerator, and it will be 2 plus 5z inverse plus 14 z raised to power minus 2, and the denominator is what? That is 1 minus z inverse raised to power 4. Actually, what we have done, we have taken z square from numerator and z4 from denominator common, and it is the result of that. And by initial value theorem, if we use the theorem is by initial value theorem. What is the initial term? That is u naught when z approaches to infinity, that is u of z. And what is that? When you take limit z approaches to infinity, 1 upon infinity will come out to be 0. Ultimately, the total limit is 0. But we require u2, we require u3. So if we require u2, in u2 we must have to use u1 and u0, because the formula of ut is this: limit z approaches to infinity, that is z square u of z minus u0 minus u1 z inverse. So this is the formula for computing u2. So if we want to use this formula, we require u0 and we require u1. So that is why we are computing the value. u0 is clear, that come out to be 0. So let us compute u1, that is limit z approaches to infinity, that is z u of z minus u0. And we have to calculate the value, that is limit z approaches to infinity, that is z into uz minus u0. u0 is 0. So when you substitute 0 here, you will left with the uz, and you can substitute the value of uz from the statement, that is 1 over z square into 2 plus 5z inverse plus 14 z raised to power minus 2, and divisible by 1 minus z inverse whole power 4. Now 1 z will be cancelled with this. Ultimately, we are again left with 1 over z. Whenever z approaches to infinity, 1 over infinity will give you 0. So the total value will come out to be 0. Now you can use the values here, that is z square, this is 0, this is 0. We have computed, and now use z, you can substitute again, that is 1 over z square, 2 plus 5 z inverse, that is 14 z raised to power minus 2, and this is a 1 minus z inverse 4. Z square can be cancelled. So ultimately this is 0, this is also 0, this will also be 0. So 2 plus 0 plus 0 over 1 minus 0 power 4. Ultimately the value is a 2. And we can also compute the next term, that is the fourth term, that is the limit z approaches to infinity. We can write down the values with initial value theorem. That is limit z cube, z approaches to infinity, and there should be z cube, and what it comes out to be u of z minus u naught minus u1 z inverse minus u2 z power minus 2. And whenever you put the values here, limit that approaches to infinity, this is z cube, uz minus u naught. U naught is 0, u1 is 0, u2 come out to be 2. So that is 1 over z square, 2 plus 5 z inverse plus 14 z power minus 2, and divide by 1 minus z inverse raised to power 4. And what is it? U2, that is 2 times z raised to power minus 2. So ultimately we have to simplify it more, and what will you get? You can take the term z square from this. Z square in the denominator can be taken common. So what is left with us? We are left with us z. So what do you have? This is the z of cube, that divided by z square is there. So you leave the z cube here, and just adjust this 1 over z square again. So what it come out to be, the original function was 2z square plus 5z plus 14, that is z minus 1 raised to power 4 minus 2 over z square. So this is mere the adjustment of the terms. We have to adjust so that we can get a finite limit. So that is the limit z approaches to infinity. This is the z cube. You can take LCM, that is z square into z minus 1 raised to power 4. So ultimately, what is that? That is that will come out to be z square will be multiplied here. It is 4z4 plus 5z cube plus 14z square minus 2 into z minus 1 raised to power 4. So you have to make the adjustment of the terms, and you can solve z minus 1 raised to power 4 separate. So that will be z minus 1 square, and that will be whole square. So z square minus 2z plus 1 whole square can be solved. That is z4, and that is 4z square, and that is a plus 1, and that will be minus 4z cube, and that will be minus 4z, and that will be 2z square. So these are the terms after finding out the 4 raised to power 4. Now you can substitute the terms here. So that is a 14z4, and sorry, this is not 14, this is 4. So this is a 4 z raised to power 4 is there, and plus 5z cube plus 14z square. Now that is a minus 2 into the terms. So minus 2 will be multiplied minus 2 z4 minus 8 z square minus 2 plus 8 z cube plus 8 of z minus 4z square, and it is divisible by that is z square into z minus 1 raised to the 4. Now we have to try to cancel the terms which are cancelable. So limit z approaches to infinity, that is z cube, and this is a 4z4 and that is minus 2z4. So that come out to be 2z4, 5z cube plus 8z cube, that come out to be 13z cube, and 14z square, and this is minus 8, 6z square minus 4z square, that is 2z square. So these terms have been cancelled out. Ultimately, you are left with the 8z minus 2. There, this is z square into z minus 1 raised to power 4. Now, you just need to make the adjustment of the terms, that is limit z approaches to infinity is here. What we need to do, 4z4 was there. So one mistake, this is while we are finding out the derivative, LCM, sorry, at this step when we are here. So when you find out the LCM here, that is z square and 2z square, that should be 2z power 4, not 4z power 4. So ultimately, that will be 2z power 4 should be there. So this is wrongly written. You just change the things, and 2z power 4 and 2z power 4 will be cancelled. So ultimately, this term is not left with us. So you just need to remove this term, and the remaining terms are as it is. Now you can simplify it more. That is z cube is there. This is already there. That is z cube into, and z cube can be taken common from the numerator, that is 13 plus 2z inverse plus 8z power minus 2 minus 2z power minus 3, and the denominator is z square is common, z power 4 is common. So ultimately z power 6 is common, 1 minus z inverse raised to power 4. So Z3 total is Z6. Cancelled with that. So when you will take the limit Z approaches to infinity, that will give you 0 because there is Z inverse 0 and 0. Similarly, there is also 0. So 13 on 1 comes out to be 13. So this is the U. So by this way, using the initial value theorem and get the required term, whatever we require. This is very important application of the theorem. Now, let us proceed further. This is a Z transformation going on. So, in the Z transformation, we have one more theorem that is a very important theorem, which is a convolution theorem. The statement is it is generally related with inverse transform, because in Laplace chapter, convolution theorem was related with the inverse of the Laplace transform. Now, in this case, it is related to the inverse Z transform of U of Z. What should be that? That is a sequence or a function of n. Similarly, we should have another Z inverse transform of Vz, and that will be a sequence function of n, that is a Vn. Then you will be able to find out the combined find inverse transformation of dz into dz, that is the summation m is 0 to infinity, that is dm into dn minus m, and that is un star dn star. This is the statement of the theorem. And what is the star? Star is the convolution operation. Here, star denotes the convolution operation. Star is the notation for the operation. Now, the theorem can be proved in this way. What is the u of z? That is the z transform of u, and that is the y summation m is 0 to infinity un z bar minus e. Similarly, v of z is the z transformation of vn, that is the summation m is 0 to infinity, and that is the vn z bar minus n. These are the basic definitions of the z transformation, and now we can find out their multiplication. We get into v of z. What it come out to be? We just open the series, and the first series is u naught plus the second term u1 z inverse plus u2 z bar minus 2 plus so on un z bar minus n plus so on into infinity. And the next is v naught, this is v1 z inverse, v2 z bar minus 2 plus so on, that will come out to be is a vn z bar minus n, so on up to infinity. This is near the multiplication. So we can multiply the terms. Whenever the term is multiplied, the first term, that is u naught can be multiplied with v naught. So ultimately, when you multiply the terms, what we should have? We should write down the coefficient of z raised to power minus n actually. So because we have to write down the multiplication in terms of series, you need to write down the coefficient of z power minus n after multiplication. So when the nth power in negative, this one is multiplied with this, you will get u naught vn and the into z power minus n, and that z power minus n has been taken common. So, and the next term should be when the next term u1 is multiplied to its previous term, it should be vn minus 1. And similarly, u2 is multiplied with vn minus 2 plus so on. The process will go on, and the last term will be nth term. Nth term will be un, and un will be multiplied with the first term of the next series, that is v naught. So this is the way to find out the coefficient. And what is n? N varies from 0 to 20. There are more multiplication terms. So these terms have been registered over here in the summation. So when you open the summation, you will get all the terms. So again, what we have, when you put n is equal to 0, you will get the first term is u naught v naught. When you put n equal to 1, you will get u1 v naught. For n equal to 2, you will get u2 So what is this? This is the other transformation. u naught vn, u1 vn minus 1 plus u2 vn minus 2 and un vn. So answer, what is this? This is the result we have. Just see what we want to do. This is the result we have. That is summation n varies from 0 to infinity. And when you put n equal to 0, you will get the series is and we put m equal to 0, we will get u naught b m minus 0 is m. The next term will be when we put 1 u1 b m minus 1 plus u2 b m minus 2 plus so on. And the term when we put a m is equal to m, we will get that is u n n minus n p. So up to so on is also there. This is there. There will be more terms. We have infinite series. So this is the theorem. This is the Z transformation. So this is the proof of the convolution theorem. And as we know, the convolution theorem is helpful for finding out the inverse Z transform. So using convolution theorem to find out the inverse Z transform of Z square Z minus A into Z minus B. Now, we have the Z inverse transform. This is the formula we have done. That is inverse Z transform of Z over Z minus A is A bar n, and inverse Z transform of Z over Z minus B is B bar n. And combinedly by using the convolution theorem, it can be written Z transform of Z over Z minus A into Z over Z minus B, and by using that will be An star Bn star. And this is the convolution theorem, and but we know that this is equal to the summation n is 0 to infinity. That should be An into B bar n minus n by using convolution theorem. And this is the summation for which m is given. So if m is given, there is no work of n here. So you can take n out and it can be written summation n is 0 to a upon b raised to power n. This is mere the adjustment of the term, and you can open the summation now. And when you open the summation, you see that what will come out to that is b bar n. For n equal to 0, this is 1. For n equal to 1, a over b, a over b square, and so on up to infinite, which form the GP. And infinite GP series is there, and sum of the infinite GP series. And how many terms are there? There are n plus 1 terms. So that is a over b raised to power n plus 1 minus 1 over b over b minus 1. Now you just need to simplify the term, and what will come out to be that is a power n minus a power n plus 1 minus b power n plus 1 upon a minus b. 1 b will be cancelled here from the denominator, 1 b from b. So this is the inverse Z transform of this function by using GP series and with the help of convolution. This is the application part of convolution theorem. Now, one more thing which we have to do, that is the convergence of Z transform. Also, very important thing. Convergence of Z transforms, and we know that what is the Z transform? Z transform of Un, that is the summation n is 0 to infinity Un Z bar minus n. This is Z transform of Un. Now, when we talk about the convergence, and the convergence should be within the range. So, arrangement, what we are talking? If we are talking about a circle, and whether the circle, the area of the circle is like this. If we are talking about the outside area, and what does it mean? Suppose we have a circle with the center origin and like this, and with the radius z is equal to a. And if we talk about the area or region of convergence, that is z mod greater than a. One case will be like this. And one more thing is, if we talk about the what is this area or this region, that is z mod greater than a modulus mean the outer part of the circle. This area will be there. This will be the outer part that is outside of the boundary of the circle. But if we say that is z mod less than a mod, it means that is the inner part of the circumference or inner region. It means the inside area will be there. This one I am talking about this. But if we have concentric circle mean, and this is a circle with the center origin, and we have one more circle inside of the inner circle. It means it is obvious that one circle has a bigger radius and other circle has smaller radius. So we can say that the bigger circle has a radius c and the smaller circle has a radius b. So what does it mean? The bigger circle means the radius b is smaller than the radius c. So when these are two concentric circles, concentric circle means having same center. So inside of the two circles, the region bounded by two circles is this one. That will be a ring-shaped region. And when we talk about this region, then we should say like that z mod is a line between B and C. And obviously C is the bigger radius. So we'll talk about region. So this is the meaning of the region of convergence, whether we are talking about outside of the circle, inside of the circle, or the region bounded by two concentric circles. Now, let us find out region of convergence with the help of a Z transform of a function. And the function is this one, that is un is 4n, that is 2n, that is 4 bar n is there, and 2 bar n is there. 4 bar n is 1, that is for n negative, and n positive, we should have a function 2 raised to power n. So we know that. One more thing, when we talk about the region of convergence, the range will be n minus infinity to not from 0 to. So in that case, that will be un into z bar minus n. The function un can also be written like this. So this is somewhat same. So the z transform of u of n, that is a summation n is a minus infinity to infinity u of n z bar minus n is there. And you can split the series. The series is n is equal to minus infinity to minus 1. And for minus infinity to minus 1, this is the interval we have. That will be minus infinity to 0, and this interval is 0 to infinity. And when we say that the interval has been separated for n is minus infinity to 1, the function is 4 raised to power n into z power minus 1 n. And when we talk about the range of 0 to infinity, and then we have the function 2 raised to power n, and this is z raised to power minus n. And just to simplify the series, we can change the parameter. And what will be the parameter? I am going to change the parameter to minus n is equal to m in the first series. First series means this is summation. So when you put m minus n is equal to m, and what will it come out to be? Then m will be from minus 1 will be changed to plus 1. So minus 1 to infinity. And that will be 4 raised to power minus m now, because n has been changed to minus m. And z raised to power n plus the summation n is 0 to infinity, and 2 raised to power n z power minus n. Now you can open the summation for m is equal to 1. What will you have? That will be 1 is m. So z power 1, 4 power minus 1. So that will be z power z upon 4. And for the next term m equal to 2, that is z square upon 4 square, z cube upon 4 cube plus so on. This will be the series we have. Next, for n equal to 0, you will get 1. For n equal to 1, 2 over z, 2 square over z square plus so on. This is the extension form of the series. So what we have, z power z upon 4 can be taken from 1 plus z over 4, z square over 4 square. If we observe, this is a infinite GP series, and if we observe this, this is also an infinite GP series. Now you can write down the sum of the infinite GP series. That is, the formula is a over 1 minus r. A is the first term and r is the common ratio. That is 1 minus z over 4 plus the next GP series will be 1 upon 1 minus 2 over z. This is the sum of the series with the help of GP formula. So what will it come out to be? Z over 4, and that will be this will come out to be, after taking LCM, this will be 4 upon 4 minus z. That will be z over z minus 2. So 4 will be cancelled, and you can take the LCM now. 4 minus z and z minus 2. So ultimately that is z into z minus 2 plus 4 into, it should be z, not 4. So you can use the LCM method, and this is z into 4 minus z. So what we are left with, that is z square is cancelled, minus 2z plus 4z, that is 2z upon 4 minus z into z minus 2. So this is the z transformation, and this is the z transformation of the given function. Now we need to find out the second part, the region of convergence. And for finding out the region of convergence, obviously when we talk about this, we are in xy plane, in which we have two circles with the center 0 and a radius bigger. This is the rough sketch of the figure. You just plot this figure with the help of a pencil and try to make circles as clear as you can. This is the circle with the center 2, and this is the circle with the center origin and radius 2 and the radius 4 is there. Now you can find out the region of the convergence in GP. We know that if we want to find out the region of convergence by using GP, the region of convergence in GP is when we have R naught less than 1. So we are using the region of convergence by using this step. So it means the finding out the region of convergence, Z over 4 should be less than 1, and from this term, 2 upon Z mod should be less than 1. So that will come out to be Z mod upon 4 modulus. And 4 modulus is somewhat 4, and that is 2 less than Z mod. So the combining region of convergence is 2 less than Z mod from here, and Z mod is less than 4. This is somewhat obvious because the 4 is a bigger number than 2. So this is the region of convergence of the given function, and what was your given function? That was u of n, function of n figure, and that lies between the angles as shown in figure. And this is the figure. Z will lie in this region of convergence, which is a ring-shaped region, as I have explained earlier. So this is the required region of convergence. Region of convergence, in short, always written as ROC. So by this way, we will be able to find out the region of convergence in every type of function. So for practice, you can do some questions at home. I give you the question. The first question is, suppose we have f of n, that is the 2 power n, and this value is for n is less than 0. We just do this question. And the second question, the function can be written in terms of f also. There is no problem message. That is the 5 power n upon n factorial, and n is greater than or equal to 0. So you do these questions as a practice, as a home assignment. So I conclude here, and we shall continue in the next class with the help of some other methods to find out the inverse gap function. Thank you very much. Thank you.